everybody. Hello there, ROS developers, and welcome to a new open class. I hope everything is fine, sound is fine, the video image is also fine. So hello everybody. Welcome to a new open class. We are going to start with the 200 number classes. So today it's 201. And the topic for today's class is going to be how robots perceive the world, which is something very interesting. And we are going to be doing some exercises, also connecting to a real robot environment by the end of the class. So I think it's going to be very interesting. And let me have a quick look here at the chat. Video is good. Sound could be louder, says Gilbert. Okay. I think I cannot do much from here. Let me see if maybe from there. This is channel number 1. Yeah, I'm going to try to speak here closer to the mic. Maybe that can do. Remember also that you can increase the volume. All right, here in the stream, you have a slider where you can increase the volume also. All right, then, so welcome everybody. Let's get started. Let me then start already sharing my screen. There we go. And as always, the very first thing that we need to do, I don't know if you are new to these open classes. If not, I see that the image is a bit off. Let me try to fix that. All right. Okay, it should be better now. There we go. Let me leave it here. All right. Yeah, it's been a while already without these classes, and some configurations here were a bit messed up, but we should be good to go. All right, then so welcome everybody. I don't know if you are new to open classes. If not, there are some names that I can see here in the chat which are familiar to me, but probably we have some people who is new. Then let me tell you that these classes are fully interactive, okay? So you are not meant to be there just watching and listening to what I am doing or what I am explaining, but you are actually meant to interact with the class, all right? So this is why I'm sharing at the beginning of the class always a ROSJECT. What is a ROSJECT? Well, a ROSJECT basically is a self-contained robotics project, okay? And how can you get this ROSJECT? Very easily. All you have to do is to click on this button that appears here above the chat, which says fork and open the class ROSJECT, okay? I'm going to click here myself, also to get a copy of the ROSJECT. And then as soon as you click here, this is going to automatically redirect you to the ROSJECT environment, which is here. Yeah. Here at the right side, you can see the streaming panel with the video, the chat also, so that you can write your questions, your comments, whatever. And this is the main ROSJECT page, which is loading. It might take some seconds, maybe up to 1 minute to fully load. Okay, in my case, I'm going to take out the streaming panel so that I have more space here for the ROSJECT, and then what I'm going to do is here open the chat so that I can still read you and everything here. There we go. Okay, and then as soon as the environment finishes loading, you are going to see something like this. Probably yours is going to be cleaner, right? But you are going to see at least the notebook being fully loaded and automatically appearing here. Okay, so this is a Jupyter notebook, and in here you're going to find all the explanations, sample codes, images, everything that we are going to be doing during today's class. You are going to be able to find it here in the notebook. Okay. Also important is that this project that I have just shared with you, you are going to have it in your account forever. Okay, so you have just created a copy of this project in your account. Then whenever you log in, you can come here to my ROSJECTs section, and you are going to be able to find this, the project for this class, and open it, review it, whatever you want to do. All right? Okay. Then so far so good. Has everybody been able to copy the project, to load it properly? You can see the notebook. Yes, no. Yes, says Miguel Angel, also Gilbert. Yes. Okay, very cool. Mine is stuck at 50%, says Raul. Don't worry, Raul, it's going to end up loading. Just wait some more seconds, okay? All right. Yeah, then the topic for today's class, as I already said in the introduction, is how robots perceive the world. Yeah, this is also known more typically in robotics as perception. Yeah, robot perception. Then for this class, we are going to have several objectives. First is understand the foundational concepts of robotics perception, identify and describe the types of sensors used in robotics, use ROS2 with the BotBox environment to perform some basic perception tasks, develop some programming skills for practical applications of sensors, and finally, we are going to present a challenge so that you can work on it, okay? Then how we are going to be working in this class? Well, we are going to work with the BotBox robot. Yeah. In the case of the ROSJECT, you are going to be able to work with a simulated version of the BotBox robot. And what is the BotBox robot, you might ask, is what you can see here. Yeah. Basically, the BotBox is an all-in-one classroom robot kit for teaching, including a real robotics lab, which you can see here being mounted, robotics courses, and practical projects. Okay? Everything is self-contained in this box, which is why we decided to name it BotBox. Yeah? And yeah, it's ideal for teaching robotics both in simulation and in and using real robots. Yeah? Which is, in our opinion, the best way to learn robotics. To be able to use both simulated and real environments. Yeah, and as I was saying, it is designed to provide hands-on, practice-based robotics classes with minimal preparation and maintenance. It is easy to assemble and can be used in various real-world teaching scenarios. Here we can see it in a university, for instance, but yeah, you can basically mount it anywhere because it doesn't take that much space. Yeah, here you can see the package that BotBox includes. Yeah, and by using BotBox, you can have full control over your students' progress with a student management panel, which you can see here. Yeah, so it's not only the robots, the environment, the projects, the courses, but also you are going to have access to a students management panel. Yeah, to see how your students are doing, to be able to manage them, give them access to the robot, etc. Right? And yeah, so here. You can find a link in case that you are interested. You can open it here and give it a look to get more details about this BotBox warehouse lab environment for teaching robotics. All right. So with the proper introductions being made, let's get started with the topic of the class. So let's start by understanding sensors in robotics. Yeah. So for us humans, it is something straightforward to perceive the world, right? We don't have to do any effort. We have our eyes, our touch sense, our ears, which help us get information and perceive the world in one way or another, right? It is something which we do automatically without even thinking, right? However, for robots, that is not that simple. Yeah, actually, it's something quite complex with many different things to take into account. But yeah, so we are going to start today with some basic concepts so that you can get started on this and at least get some foundational knowledge. Yeah. Then, how do robots perceive the world? Well, robots perceive and interact with the world basically using sensors. Yeah. The sensors would be, let's say, our eyes, our ears. All these would be our human sensors. Yeah? And robots have their own sensors in order to perceive and interact with the world. Yeah? Some of the most typical ones are cameras, for instance. Yeah? Cameras are capable of capturing high-resolution images and videos. Yeah? And they can be used for many different tasks in robotics, such as vision-based perception, object recognition, object detection, face detection, line detection, and line following. Yeah, so you can use camera for many different things in robotics, and it's probably one of the most important sensors that a robot can use, right? Another very important sensor are lidars or lasers. Yeah, so lasers, probably you are already familiar with them, emit laser beams to measure distances by calculating the time it takes for the light to reflect off objects and return to the sensors. Yeah? LiDARs, for instance, are one of the most important sensors when it comes to autonomous navigation. Yeah? For being able to perceive the robot environment, for generating maps of the environments where the robot is going to be navigating, for obstacle avoidance, path planning. For all these autonomous navigation tasks, LiDAR sensors are crucial, are very important. Then there are other kind of ultrasonic sensors also that can be used for other things. Odometry sensors, for instance, this is another one which probably it sounds familiar to you. Yeah, and odometry sensors are crucial for tracking a robot's movement over time. Yeah, they provide information of how the robot is moving around the environment over a certain time. Yeah, and it's also very important for tasks related to autonomous navigation, such as localization. Yeah, it's very important for the robot to be able to know where it is at every moment in a certain environment, right? For path planning, etc. Yeah. And other sensors such as IMUs also, and there are more, okay? Here I just wanted to introduce some very typical and very important sensors which are used in robotics, okay? In the BotBox, of course, we have several of these. We have a LiDAR sensor, which you can see here in blue at the top of the chassis. We have also an RGB camera. We have odometry also to get information of how the robot is moving over time. And we are going to be using a couple of them during today's class. Specifically, we are going to start with the laser, okay? Then, how we can interact with robots' sensors. Let's have a look at this. Alan McDonley is asking, is Turtlebox purchasable separate from the whole package? Yes, it is. You can purchase only the Turtlebox robot also. Yeah. And Atul Kumar says, example of odometry sensor, wheel encoders. Exactly. Yeah, that is one of the most typical ones, wheel encoders, to track the spinning of the wheels. Yeah. These are P-based. I don't know what you mean with that question, Danko. All right. Then we are going to start by launching a simulation, yeah? So if we want to be able to start interacting with the sensors of the robot, we need to actually have something running, right? And for that, we are going to be using a simulation of the tortoise bot, which you can see here. This is a simplified version of the simulation, okay? Then how can you launch this simulation? Very easy. You have the instructions right here, yeah? You need to execute these two commands and nothing else. Why? Because this environment, the ROSJECT environment, already has ROS installed, already has Gazebo installed, and already has everything needed to start a ROS-based simulation, okay? So you don't need to worry about installing things, no. Just straight execute the commands and launch the simulation, okay? What we do need is to have a terminal, yeah? An available terminal or shell where we can execute these commands. Then how to open a new shell? Very easy. You have to come here to the bottom part. Here you have all the different icons, and the very first one, right here, it says web shell. I don't know if you can see it properly. Yeah, you can see it here. You can see it here in the stream also. So the first one, which says web shell, if you click on it, this is going to automatically open a terminal. Yeah, this is just like a regular Linux-based terminal, yeah, where you can execute commands. All right, nothing special here. And then what I recommend you to do is to basically just come here, select the commands, yeah, copy them, yeah, or you can also copy them directly here with this button at the right side of the cell, yeah, and then you come to the terminal and paste, yeah, and this is going to automatically execute the command and paste it here, yeah, and then all you have to do is to press enter, and this is going to execute the command to launch the simulation, yeah. The source command is important in order to source this specific ROS2 workspace, which is the one that contains the simulation files, and then the ROS2 launch command is the one that starts all the simulation and ROS related processes, yeah? Then after some seconds, you are going to see the Gazebo window pop up, yeah? And if everything goes okay, we are going to be able to see the simulation as I can see right here, yeah? This is the Gazebo simulation already running. Okay, now, in some cases, okay, there might be, you might get some errors with Gazebo, yeah? So, what I recommend you to do is one thing, is once you have the simulation running, we open a second terminal, okay, by pressing here on this add icon, which says create new terminal, okay? Why? Because this one is the terminal where the simulation is running, yeah? So we don't want to stop it, close it, or anything. So what we are going to do is to open a second terminal to be able to continue working and executing commands, okay? Then here, for instance, you can run a ROS2 topic list, right? And make sure that you can see the simulation topics, yeah? Okay, so here, for instance, I can see the camera topics, command bell topic for being able to send velocities to the robot, the odometry topic, also the scan, which is the topic for the laser, yeah? And furthermore, to make sure that everything is working, you can also run a teleop twist keyboard program, okay, which is the basic program provided by ROS in order to control and move a robot using the keyboard, yeah? So let me execute this here. And then here, using these keys from your keyboard, yeah, you can control the robot and move it around, yeah? Here, let me show you, see, how I can control the robot and move it around, also rotate it, etc., yeah? So this tells me that my simulation is loaded properly and it's working, yeah? Raspberry Pi. Ah, yes. Yes, Danko. They are based on Raspberry Pi, yes. Which Gazebo version is the ROSJECT using? This one is using Gazebo Classic 11, if I don't remember wrong. Okay, actually I think there is a command here, GZ version or something like it. Oh, sorry, I need to change here my... Wasn't there some command to check the version? No. Well, I don't remember now how it was but also here in the logs of the simulation, probably we are going to be able to see it. It's Gazebo 11. Okay, so the version used is 11, Gazebo 11. Looks like Ubuntu. Yes, this is that is because this is an Ubuntu system. Okay, so here what you are running is an Ubuntu computer in the cloud. Okay, and in this Ubuntu computer there is already ROS2 installed, Gazebo installed, and many other dependencies, so that you can just open the ROSject and start working with ROS without having to worry about installation, dependencies, etc. Yeah. Here we want to focus on learning ROS, yeah? Not on installing packages and having to handle all that stuff, but just go straight to what really matters, which is learning and practicing. Okay? Then, is it working for everybody, the simulation? Are you experiencing any problems here? My robot didn't spawn in Gazebo, says Raul Ochoa. Okay, perfect. That's what I wanted to see. In some cases, you might have some problems, okay? If that happens to you, don't worry. All you have to do is stop the simulation, okay? Let me here stop the simulation with Control-C. If you press Control-C in this terminal, the simulation process is going to stop, and it's going to free the terminal, as you can see. And then, right below here, in the notebook, you can find the instructions to kill the current Gazebo processes. It's basically executing this command. So let me copy and paste it here. You will see that this is going to kill the simulation when I run it, see? And then after this, you can just execute again the command to launch the simulation, okay? And very likely, the second time that you execute it, simulation is going to load properly, okay? If not, you can repeat the process, but usually, if it doesn't work on the first try, the second one is going to load, okay? Because the first one sometimes fails because of some timeouts related to Gazebo and so. Can you paste here the code for manual commands? Sure. I didn't add this one to the notebook. So this is the command to control the robot using the keyboard, okay? I'm going to paste it here in the chat. Put it again. There you go. ROS to run, teleop twist keyboard, teleop twist keyboard. It worked now, says Raul, also Miguel. Excellent. Okay, so now we are ready to go. Yeah, we have a simulated version of the BotBox environment with our robot here, which has the sensors running. Yeah, we have seen here. Let me run again the command ROS to topic list. And here I can see several topics, like topics related to the camera sensor, topics related to the laser sensor, topics related to the odometry. Yeah. However, what happens if I try, for instance, to visualize the laser topic? Yeah. So as you might know, ROS to topic list, it's the ROS to command in order to list all the topics related to a robot. Okay, in this case, to the BotBox. But you can also access the information and read the information. How? That is done with the ROS to topic echo command. And then you specify the name of the topic. For instance, here I'm going to read to subscribe, yeah, actually the word, the proper word, the proper term in ROS2 is subscribe to a topic, yeah? And basically subscribing means to read the information that it's being published into a topic, yeah? So now I'm going to subscribe to the information of the laser, yeah? Then here, for instance, I'm going to start getting a bunch of numbers which are very hard to understand from a human perspective, right? I can see here many numbers, many data, but honestly, this doesn't make much sense to me, yeah? So what can I do in order to properly visualize the sensor information of the robot? Okay, so for that, we can use a very interesting tool, which is RViz, yeah? Then in the next section, we are going to see how to visualize and interpret sensor data using RViz, okay? Then the very first thing that we need to do is to start the RViz application, yeah? And that can be done with the following command, yeah? So let me copy the command here from the notebook, and then here in the terminal, I'm going to execute it, yeah? And after a few seconds, you are going to see a window popping up. There you go. And this is the RViz application window, okay? You can maximize it here if you want to see it better, yeah? Then let me go back to the notebook. So first of all, very important is to select the frame, yeah? This is a concept, a basic concept, but sometimes it can be a little bit hard to understand, yeah? But in robotics, sensor data is always associated to a frame of the robot, yeah? For instance, the data that the laser is publishing, it is associated to a specific frame, yeah? Okay, in any case, let's not get into too much detail because otherwise we are not going to be able to advance, yeah? Then, in this case, we are going to set the fixed frame in RViz because also whenever we visualize sensor data in RViz, we visualize it with respect to a reference frame, right? And in this case, the reference frame that we are going to select is going to be base link, which is basically the base of the robot, yeah? The base of the robot, it's somewhere, this base link is going to be here in the center of the robot, approximately here, okay? So it's a very common reference frame for a robot, base link, yeah? Then, how to set this base link as the reference frame for RViz? Well, here you come to the fixed frame field, yeah? And then here you are going to have different options, yeah? You can select different frames from the robot, but we are going to select the first one, which is base link, okay? And then just press enter, and that's it, yeah? And now we are going to start adding displays. For instance, let's just start with the camera sensor, okay? Again, with the camera sensor, we have the same problem as with the laser, right? We can try to visualize the data through a terminal, right? For instance, ROS2 topic echo, and then let me select this one, copy, and paste, yeah? This is the topic where the camera publishes, yeah? So again, I'm going to start here seeing a bunch of numbers which make very little sense for me, from a human perspective, right? Then, let's try to add something here in RViz, a display, so that we can visualize actually the information, the data published by the camera of the robot in a way which is easy readable for a human, for me in this case, yeah? So how to do this? Well, we need to add a display which is named image, yeah? You have it here also in the visualization part of the notebook, yeah? Then How to add a new display to RViz is very easy. You come here to the Add button, right here, and then press this Add button. And here, this is going to open a list with many different displays, yeah? Then here, all you have to do is to scroll down and look for the image display. Here I have it, image, okay? And then double click or okay, and this is going to add a display button, okay? So now the display, the image display has been added, but we need to configure it properly, yeah? What does it mean to configure it properly? In this case, basically is to tell in which topic the data is being published, yeah? In our case, for our robot, we know that this topic is camera/image raw, yeah? So what we are going to do here in RViz is to open the display configuration, and in the topic section here, we are going to click here in the right side, and then select the option camera image raw, which actually here is the only one available, yeah? So we select this option, press enter, and then suddenly we start seeing here the camera data from the robot. Let me make this a bit bigger, if I can, somehow. Cannot manage to select it. There it was. It's almost a pixel perfect place. Okay, let me make it a bit bigger like this, and then got it. Okay, there we go. Okay, yeah. So this is the camera image again. Let me execute the teleop so that I can move the robot around, and you are going to see how the camera data is constantly updated, yeah? Teleop twist keyboard, and teleop twist keyboard again, yeah? So now you are going to see that if I move the robot, for instance, rotating it a little bit, let me put the camera view here, yeah? So I'm going to start moving the robot in the simulation, and you are going to see how the camera image reads, updates properly, yeah? So this is, without any doubt, a much better way of visualizing the camera sensor, right? Than trying to understand all these numbers that are published here in the topic, yeah? This is much more human-friendly, yeah? And we can do this for any sensor, yeah? For instance, let's continue with the laser, yeah? Again, we also saw that the laser topic contains just a bunch of numbers, yeah? But we can also visualize this data properly using RViz, okay? Let me try to move this back here if I can. No? Okay, let me just put it. Can't I move it back here? No. Ah, there we go. Okay, whatever. Let me just remove it and add it again. I'm going to finish earlier. Where it is, image, there we go. And then topic, camera, image, raw. Okay, there we go. Let's leave it here in small, because now I want to add another display, which is a display so that I can visualize in a more understandable way the laser data. Okay? Then for this, we need to use the laser scan display, okay? Which you are going to find again by clicking on the Add button and then scrolling down over the list of displays, yeah? The one for visualizing LiDAR data, laser data, is laser scan. So we double click here, and again, I need to properly configure this display. How? By providing the proper topic name. So let's go again to the topic section, and here in the right side, we select the only option available in this case, which is scan. Yeah, RViz, as you can see, automatically filters by messages. Yeah, so it's not showing all the topics, but only the ones which apply to this display. So let's select the scan display and hit enter, and then we can see now the following. Yeah, what is this? Well, these are all the laser beams, yeah, which are crashing against something and coming back to the sensor. Yeah, so basically this indicates the walls that the robot in the simulation is detecting, right? Let me move. So exactly in this case, it's this specific squared area here. Yeah, these walls here. If we put it here, yeah, let me put it here side by side like this, and then so that you can see it properly, yeah? This is something more or less like this, yeah? This is the robot with the laser, and this is the environment, the room where it currently is, yeah? So this would be something like this, right? See it now? Yeah? This is the entrance here, down here, and then the walls, and the corridor here at the top right corner. Yeah? So this way, it is much more easier to understand. Oh, okay, so this is the data and the objects that the laser is detecting, right? This is a visual way, and it's much more easy to understand and interpret the sensor data, right? Let me have a quick look here at the comments. I'm not getting. Can you please repeat? Can you repeat that part, please? What part do you mean, guys? Which part do you want me to repeat? Miguel says, when I click on topic, it doesn't appear the camera topic. You have to click, Miguel, you have to click on the right part, not here, okay, but here, in this right side, okay? If you click here, you should see here the menu here with the topic options, okay? Dustin says, I selected topic scan, but RViz 2 is showing 0 points from 0 messages. Okay. In that case, Dustin, my guess is that probably your simulation is not working properly. Okay? So just try restarting the simulation, as I explained it earlier. Okay? Because that could be a reason for you not being able to see the topics here in the simulation. Yeah? And ROS to topic echo scan is showing messages, you say. Okay, then that's something different. If ROS to topic echo scan is showing messages, then yeah, then try removing it and adding it again, because it doesn't make much sense. If you can see the messages in RViz, you should be able to see them in RViz also, unless you changed some configuration here or you are not using the base link fixed frame. Okay, so make sure that the fixed frame that you are using is base link and not another. Okay, this is the very first step that we did. Reference frame has to be base link. If we change and put, for instance, Odom, which I don't know, I think it's map, the default one, yeah? If you put map, if you have map here, which is a frame that doesn't exist in this simulation, then you are not going to be able to see any information, yeah? So you have to put one frame which is known for the camera. Okay, then it was that problem, the fixed frame, right? Okay, what else? Odometry. Yeah, odometry is another very important sensor that we already introduced that also can be visualized using RViz, as all sensors in robotics. Yeah, for the odom, it's pretty simple. Again, same process. You click on the Add button to add a display, and then look for the odometry display, which is right here in my case, odometry. Yeah, double click, and same process. Always it's the same. You add the display, and then you have to configure the display for your specific robot. So in my case, I go to topic, to the right side, I click here, and then I select the proper topic, which is odom for my robot. And then you are going to see this here. My suggestion is that you uncheck the covariance, okay, because it's what it's adding this kind of mess here. If you unselect and mark the covariance box, it's going to be much more clear. Yeah, and then here we can see the current position of the robot, which is right here, looking in this direction. Yeah, in the right side here of the entrance and facing this specific orientation. Yeah, if we look at the simulation, we can see that, yes, so the robot is here in the right side of the entrance and with this specific orientation, yeah, looking in that direction. Yeah. And again, if I move the robot, I'm going to see this being updated. Yeah. Let me move again a little bit the robot around. Yeah, let me move it forward here to the center and then rotate to the right a little bit, facing the north of the room. There we go. Rotate a bit more. Okay, and then let me stop here. Okay, and if I go back to RViz, I'm going to see how the odometry of the robot has properly updated accordingly to the new position of the robot. Yeah? Okay, and we have one more yet, which is the robot, a couple extra, okay? But actually, this is not a sensor, okay? But it's a very useful tool that RViz provides, yeah? Every simulation and real robot also publish the robot description into a topic named robot description. Yeah. What does this topic contain? It contains the definition of the robot, the URDF definition of the robot. Okay. I'm not going to enter into details again because it's not the focus of this class. But this allows you to visualize properly the robot. Yeah. And again, it's very simple. Same process. We go to add. We look for the robot model display, in this case, which is at the bottom part, robot model, double click, and then we need to configure here the topic, which is at the bottom part here, yeah? Description topic, right here. Then we click on the right side and we select robot description. Press enter, and what does this do? As you can see, this adds the URDF definition, yeah, the visuals of my robot, yeah? And this is very helpful also in terms of visualization because we can see exactly where our robot is, okay? This is not a sensor, but it's an interesting tool that ROS provides and that we can take advantage of using RViz, yeah? So here we have a complete display with our robot, the odometry, the laser readings, and the camera. Yeah. My suggestion now is that you do the following. You go to File, Save Configuration As, and then here let's go to User, ROS to Workspace, SRC, and then you can give a name to the file, whatever you want. For instance, BotBox. Save. Yeah. And now, whenever you open again RViz, let me stop RViz, yeah? Because this, configuring and setting all this takes some time, right? So now, whenever you open again RViz, you are not going to have to do all this process over again, right? Now, you can just go to File, Open Configuration, and you look for the file that you have just saved, which is here, BotBox RViz, and directly load it, and you have it available. Okay, from the scratch, without having to do all over again. Yeah? Okay. So far, so good. Have you been able to complete the visualization process for all the sensors in RViz? Yes, yes. Okay. Awesome. Okay, then let's continue. Because now, well, actually, let's do one last thing, okay, which is to change the color of the laser readings, okay? This is not mandatory. I'm going to do it just for visualization purposes, because later I'm going to add another marker in red. So let me change here the laser. You don't need to do this if you don't want, okay? This is just optional. I'm going to go here to the laser configuration and then change the color transformer to flat so that it shows white, okay? Actually, here you can select in which color you want to visualize it. You can put it, for instance, yellow or whatever you want, okay? All right. Then what I want to do now is the following. I want to create some program that actually uses the robot sensors for something useful, okay? What are we going to do? In this practical example, what we are going to do is to use the laser sensor in order to detect walls in the environment, okay? Then for this, we need to do several things. And I have provided already here the code, a basic version of a ROS2 program that does this, okay? Then, altogether, let's now start by creating a new file, okay? So we need to create a new file here in ROS2 workspace, which is named like this, yeah? Then, in order to do this, let's open the code editor, okay? The ROSJECT environment also contains, of course, a code editor, which you can open here by pressing on the second icon in the bottom bar, which says code editor, okay? This is going to open a code editor, which is going to give you access to all the different folders, workspaces, and files which are inside this ROSJECT, okay? I don't know why this is showing like this. So let me refresh. There we go. Okay? Then in this case, we are going to go inside ROS2 workspace, SRC, and here is where we are going to create our new Python file, yeah? So right-click, new file, and then we are going to name it walldetector.py. Okay? There we go, walldetector.py. Okay? And then all you have to do is to select the code here from the notebook, select all the code, copy it, and paste it into the code editor. As simple as this. Paste. No, sorry. Oh, sorry. It looks like I didn't copy it properly. Let me repeat it. Copy, and then paste. This is not working for some reason. Let me do it with the shortcut. There we go. Okay. All right. So, create new Python script inside your ROS2 workspace SRC folder. Okay. And then copy and paste the code from the notebook into the code editor. Okay. Yeah. Then I'm going to now execute the code, and afterwards I'm going to explain a little bit what is going on in that program. Yeah. So in order to execute the code, all you have to do is execute the following commands, again, that appear here in the notebook. So let me do this here in a new terminal. First of all, we move to the proper folder where the Python script is, walldetector.py, and then we execute it directly with Python in this case. Python 3 walldetector.py. Okay? And then, actually, in order to, so apparently nothing is happening, right? But in order to see the effect, what we need to do is to add a marker to RViz, okay? But before doing that, let me do an overview of the code, okay? Very quickly. I'm not going to go into details because we are running out of time for the class. So I'm going to do a quick overview of the different parts of the code. It's not very complex, okay? As you can see, not too complex. Then, basically, we have a Python class here where, very important, we are creating a subscriber. Yeah? We are creating a subscriber for the scan topic. Why? Because we are going to use the laser data in order to detect walls. Yeah? So if we want to use the laser sensor, we need to subscribe to the laser sensor. Yeah? So here we are defining the subscriber. And then we are also creating a publisher to publish information to a different topic, which is visualization marker. Okay? Why? Because the walls that we detect with our algorithm, we want to publish a marker so that we can visualize them properly in RViz. Right? Okay, then let me go back to the code. Then this is the callback for the laser. Yeah? Whenever a new laser message is received, we are going to execute these lines of code. Yeah? In this case, here we are doing two things. First, we call the function detect walls, and second, we call the function publish markers. Yeah? Which are functions from this class. Yeah? So actually they are methods. Here we have the detect walls method, and down here we have the publish markers method. Yeah? So for every new incoming laser message, we are going to first execute the detect walls method, and then to be able to detect the walls, extract the walls information from the laser data, and second, we are going to publish markers for visualization purposes only, okay? These markers are only for visualization purposes, okay? Then here we have the detect walls method, okay, where we are basically using some distances and a quite basic algorithm, which is this one, compute wall length, okay? We are measuring the reading from the laser and then checking the length and more or less detecting or filtering what we think are walls from the laser readings, which, remember, again, is this information in yellow here. Yeah? And then once we have the information, we are publishing this information, these detections, as markers. Okay? All this is only for visualization purposes. And where are we publishing these markers? We are publishing them in this topic, visualization marker. Okay? So now let me go back to executing the program here, wall detector, and then now I'm going to go to RViz and add a new display. Let me add a new display here. In this case, the display that I want is this one. It's named marker. Okay? So I'm going to add a marker display. And again, for the topic, I want to select visualization marker, yeah, which is the topic where I am publishing the marker information. So let me select here the visualization marker, press enter, and then I'm going to see something like this. See? So these are the markers that I'm publishing. As you can see, it has a slight small errors, okay? This is normal because the algorithm is very simple, but you can see the idea, yeah? So we are getting the sections of the laser and then generating a marker right here in order to indicate more or less where there are walls, okay? Yeah, this can be fine-tuned, improved in order to make it more accurate, okay? But you can see that it makes sense, at least, right? Yeah? And this is a practical example of how to use sensor information for a robotic application. In this case, is detecting walls and publishing markers for the walls. All right? I want to make the odom arrow length. You can change that in the configuration here. I think it's in the shape. You have here the head length, shaft length, so you can make it, you can configure here how the arrows look. Even change the color, whatever you want, okay? For instance, I am going to put it in green. Yeah? And the shaft length, for instance, you can reduce it here to half, 0.5. All right? Dustin asks, will we be able to save the workbook after the class to recreate it in our local? Yeah, so this project, as I explained it at the beginning, you have created a copy of this project in your account, and you have that forever, okay? So if you come here in your deconstruct account, if you go to the My Project section, you are going to have a copy of this project basically forever, right? So you are going to be able to access all this notebook information, environment, everything, whenever you want, okay? Tomorrow, next week, or next month. So yeah, you have it for forever, not only for this class. Sure. Okay, then here we have the practical application, and then here you have an explanation with a bit more detail about the wall detector program and the different things that we are doing. Yeah, we are applying some thresholds to consider what we think is a wall, what not, etc. Okay? But I will leave all this for you to give it a look with more time, because I want to do two very quick things. First of all is to introduce you the challenge for today's class. Yeah? The challenge for today's class is to, let me stop already here my program and the simulation. No, actually the simulation, no. I'm going to stop only, not yet, okay? So the challenge that I want to present to you, so that you can work on it in the following days, is to use the camera information to detect text in the floor. Yeah. So if you pay attention, there are different parts of the environment where there are some letters, some texts written, right? So I want you to use the camera information, the camera sensor, in order to detect this text in the floor environment, in the environment floor, okay? Yeah? Then you have some details here, and also you have a code snippet, a sample code, okay? Which I'm going to create and execute very quickly to show you how it works. You can, this is how I am naming it. Okay, let me name it, for instance, detect text.py, and then I'm going to paste the code here, okay? And let me execute it. Well, actually here I have RViz. Let me load my predefined configuration. There it is. And then here I'm going to execute my program, Python 3 detect text. Okay, never mind. Okay, and now if I come here to the graphical tools, I'm going to see something appearing. I should see in a moment. Okay. There we have it. Okay. So as you can see, this is a new window that is appearing. Okay. This is basically an OpenCV generated window. Okay. OpenCV is a library for image processing, if you are not in case you are not familiar. And as you can see, it's kind of detecting some things. It's not working very well, but for instance, down here it is detecting some text. Yeah, this one it's not detecting it, but we can try to move a little bit the robot and see if it improves. Actually, here we can already close RViz because we don't need it. So let me just run here ROS to run teleop twist keyboard and teleop twist keyboard. Let me move the robot a little bit around here. For instance, let me move here to face these process 2 and process 4 sections. Let's see if we can see something here, the program. Let me go back here. Yeah, and as you can see, it's detecting this process 4, also this process 3 here, more or less well, okay? You can see some errors here in the right side, yeah? But this is a starter code, okay? So what I want you to do is to analyze properly this code, understand what it is doing, okay? You have some tips here, okay? Basically, very quickly, we are subscribing to the camera topic in this case, and then we are using OpenCV in order to detect edges, okay? We are using the Sobel filter to detect edges, okay? And then we are doing some filtering, but I'm going to leave that for you so that you can properly check what's going on here. We are using OpenCV for that. You are going to learn how this properly works, and you are going to be able to improve the code in order to make it much more reliable, okay? You are going to see that right now it's working pretty well, but it can be improved, okay? Then that I'm going to leave it for you as homework. And as a last thing before closing, I want to show you a real robot example, okay? So I have here, from a ROSJECT environment, you can also connect to a real robot directly, okay? Without having to do anything additional. In this case, I have created a lab for the BotBox, and I can connect just by clicking this button here, okay? Let me do it right now. So if you get a BotBox set, you can configure a lab like this in 5 minutes, okay? It's super, super simple. I have one configured here in my offices, and you are going to see this in a moment. Yeah, this is the camera that I have set up, and this is my BotBox environment with the robot right here, okay? So right now I am connected already to this real robot, yeah? Then let me open a terminal just to show you very quickly this. And I'm going to execute, for example, the ROS to run teleop twist keyboard. Teleop twist keyboard. Okay? And right now already, let me reduce the speed so that I don't crash the robot. Yeah, you can see how the robot, right now I am controlling the real robot here from the ROSJECT. Okay? Yeah, I am rotating it. I can move it forward, backward. Let me put it here in the center, rotate a little bit, yeah? And same goes with RViz, yeah? For instance, I'm going to right now start RViz and visualize data for this robot. Let me select the base link and let me add, for example, the laser scan, okay? I need to select the scan topic, and here we are going to, it was not selected, there we go, yeah? And here there is something interesting that happens, yeah? Is that I cannot visualize the topic even though I have added the topic scan, yeah? Why is this? Well, in this case it is because the real robot has some different QoS configurations. Okay? I know what's going on here because I have the experience, but in this case, what I need to do is to change the reliability policy to best effort. And then the laser data appears. Okay, here you can see the laser data for the real robot. Okay, what I wanted to show this to you? Well, because switching from simulated environment to a real environment, yeah, always is going to enforce you to understand that there are some things that always are going to change, which is known as the reality gap between simulation and real robot. Yeah. Okay, and this is something that it is achieved very well by the BotBox lab, because you can work with simulation and then switch to a real robot, and this is going to provide you a really, really high value knowledge, which is being able to switch between simulation and real robot. Yeah, because you are going to see that in the real environment, some things don't work, and you need to take those things into account. Yeah. Okay. And again, for instance, you can we can execute also the wall detection program in the real robot, and it's also going to work different than how it worked in the simulation. Okay. Yeah. But I wanted to very quickly connect here to the real robot to show you this example, and with the real BotBox environment. So yeah, then I'm going to leave it here. I'm already past the time. So I hope that you enjoyed the class. I hope that you liked it. I hope that you have learned something new. I have given you some programs there so that you can review it at your own pace and work to understand them better, to improve them. Alan says, like my real robot does not drive straight, but the odometer says it did. Yes, exactly. It was awesome. Thanks a lot, says Miguel. Thanks to you, Miguel. Really, really appreciate your words. Link to BotBox purchase. Alan, you have it here in the notebook at the top. Here in the top of the notebook, you have the section explaining and showing some images of the BotBox link. And here you have the link in the Get More Info. Okay, if you open this link, this is going to take you directly to the BotBox page with more information, and you can order it and etc. All right? You have all the information here in the notebook. Okay, then I'm going to leave it here. Thanks a lot for being here today with me. I hope that you liked the class. I hope that you enjoyed, that you learned something new, and I hope that you can continue practicing with the ROSJECT and share with us whatever you achieve with the text detection or with the wall detection or any other program that you want to try with the BotBox simulation. Share with us anything that you achieve. You can record a short video or images. We would love to see that. And yeah, see you all in the next one. And as always, until then, keep pushing your ROS learning. Bye-bye.